point? Any questions? So these points were already discussed last time, so there is nothing new here. Okay, so you can easily do these calculations, and then for this YY connection, we can apply now KVL, and then we get IA. You can write IA equal to VAN by ZY. Okay, it's simply coming from that KVL, and IB also we can write. Similarly, IC you can write, and then you have from this KCL that IA plus IB plus IC must be equal to 0. Correct. So if IA plus IB plus IC equal to 0, that automatically means that IN, which is actually equal to negative of this, will also be 0. And so VNN, that is Zn into IN, will also be 0. So that means they are neutral, this small n and this capital N. So one is, remember, one is source, the other is load. We are taking as load. Okay, so voltage across neutral line is 0. So we can ignore this line. That's why if you remember in the previous slide, in the previous lecture, I had not drawn this. So, so because this is going to be 0. So, and phase current, this we have already defined. Okay. So in YY connection, in YY system, you can see that I line current is same as this phase current. Okay. Whatever line current you have, that is same as phase current. How can you see this? Yes, Adhiraj. Can you see this, that why line current is same as phase current यहाँ पे for YY connection? Why it is so कि we are taking IL equal to I phase? Adhiraj चौधरी.
यस सर.
हाँ जी, बताइए क्यों ऐसा क्यों है?
सर कैन रिपीट, मतलब समझ नहीं आया.
Why I am saying कि line current is same as phase current? Why it is so in case of YY connection? We had defined line current also last time. We had defined phase current also in the last lecture. But why line current is same as phase current? Can anyone explain? Can anyone see the reason that why or how? What is phase current? phase current क्या था? हमने define किया था ना last time.
सर ईच फेज से जो करंट आउट मतलब सोर्स से जो करंट निकलता है.
And line current?
Line current is the current in line through the load.
In the line through the load. अच्छा.
Define ठीक से नहीं कर पा रहा हूँ मतलब.
Okay. Have you students have you seen that I posted that key which chapter you need to refer from the book for 3-phase networks?
यस सर.
Yes sir, 17-18.
हाँ, मिल गया ना वो चैप्टर, मतलब आपको मिल गया ना वो मटेरियल की कहाँ से पढ़ना है ये 3-phase वाला? सो देखा है अभी किसी ने उसे? नहीं,
बट बुक नहीं मिला सर.
हाँ बुक में ही, आई एम सेइंग बुक में ही वो चैप्टर है. वो बुक नहीं मिल रही है, ये बोल रहे हो?
हाँ जी सर.
अच्छा, बुक नहीं मिल रही है. अब ये तो वही, ये तो आप लोगों को पहले ले लेनी चाहिए थी बुक. इसमें बुक क्यों नहीं मिल रही है? ऐसी तो वो बुक है, इजीली अवेलेबल है. दैट बुक इज इजीली अवेलेबल. यू कैन इनफैक्ट ऑर्डर इट ऑनलाइन आल्सो इफ नथिंग एल्स. और कुछ नहीं तो आप इसे ऑनलाइन ऑर्डर कर सकते हैं. दैट यू विल गेट इन अ डे, इन 1 or 2 days यू विल गेट. सो ये तो रीजन.
सॉफ्ट कॉपी ढूंढते थे ना, क्योंकि सर अभी कई एरिया ऐसे हैं जहाँ जैसे अब जो न्योल के यहाँ वो आ रखा है साइक्लोन इस टाइम. तो एक लड़की है वो लद्दाख रहती, तो ऐसे बच्चों को सॉफ्ट कॉपी चाहिए ना सर.
ओके,
उधर के लिए प्रॉब्लम है सर. हम तो कैसे करके ऑर्डर भी कर लेंगे. हाँ जी सर.
तो उनके लिए प्रॉब्लम है. लेकिन साइक्लोन और ये सब तो अभी आया होगा ना, जो भी इशू है जो आप बता रहे हो नेचुरल, ये सब तो अभी आया होगा ना. मे बी लास्ट वीक से आया होगा, लास्ट 10 days से आया होगा.
क्योंकि आपने जो पहले बुक कही थी ना वो थी नेटवर्क
एनालिसिस अवेलेबल है क्या उसका, मतलब
किसमें?
पीडीएफ कॉपी आई बुक?
नहीं पीडीएफ नहीं, मैं तो एक्चुअली हार्ड, मेरे पास तो हार्ड है, उसकी हार्ड कॉपी है. सो इसलिए आई डोंट नो अबाउट पीडीएफ. आई डोंट हैव पीडीएफ वर्जन ऑफ दैट. बट व्हाट आई एम सेइंग इज कि जो भी है, बिकॉज दैट बुक इज ऑलरेडी देयर इन टेक्स्ट बुक आल्सो, योर सिलेबस आप चेक करेंगे So that book is mentioned there. So but otherwise I told you कि इसके अलावा I will be referring to many other books. So definitely आप वो बाकी सब books तो नहीं खरीद सकते ना. You cannot buy 5 books for this course. But textbooks you must have at least. Okay, at least textbooks you must buy. That's what my advice is, because it's always better to read from book also. But fine, it's okay. So I have already given all the things, like all the material that were possible I have already given, and I have also posted the assignments. There will be like maybe with one group we may not be able to have tutorial, but I'll post the assignment and the solution in that group also. So please go through those assignments and solutions. There may be some minor corrections in those, like something is missing, some information is missing in assignment, but that information will be given in solution. So there will be one or two such problems that you may find, but I think you will understand at least the methodology of solution. हाँ बोलिए
सर मैं एक डाउट है, जो हमने IBM में हमने उधर -120 लिया है ना,
हाँ
तो हम अगर हम उसके जगह सर +240 भी तो ले सकते थे सर.
हाँ ले सकते हैं, बिल्कुल ले सकते हैं. सो वो हमारे तभी तो हमने बोला कि इट डजंट मैटर ना, आप उसे -120 लिखे या +240 लिखे. हम तो एक उसको लैग वाली उसमें लिखना, पॉजिटिव सीक्वेंस हम ले रहे हैं ना. एक्चुअली यू कैन राइट इट, फाइन, आई एग्री विद योर पॉइंट. बट जो हम जो सीक्वेंस डिफाइन कर रहे हैं, डिफॉल्ट एक स्टैंडर्ड रेफरेंस होता है ना, कि हम ये रेफरेंस फॉलो कर रहे हैं. तो व्हेन यू आर सेइंग ABC सीक्वेंस, ओके, जैसे हमने ये ABC, सो दैट विल ऑटोमेटिकली इंप्लाई दैट व्हिच इज लैगिंग व्हिच इज लीडिंग. ओके, अगर हम एक स्टैंडर्ड नहीं डिफाइन करेंगे, देन हाउ विल यू नो कि इट्स 120 डिग्री लैगिंग और लीडिंग? क्योंकि एवरी टाइम वी यूजुअली डोंट से ना कि इट इज.
सर एक बार बैक करना एक बार वो ABC वाले पे. सर देखो सर, वो ABC वाले पे जिसमें हमें ये जो आपकी +120 है ना, ठीक है सर. पर सर इसमें तो ये तो दोनों डायरेक्शन में फ्लो कर रही है सर. जैसे मैं कौन सा समझू, देखो एक +120, एक नीचे से जा रही है -120, तो ये भी पॉजिटिव और ABC सीक्वेंस है सर. तो फिर सर इसमें भी दोनों
आप डिफरेंस देखिए ना, ये A है, A हॉरिजॉन्टल में है, देन नेक्स्ट इज C. हियर C इज this -120 degree from A. In this case, the first case, C is -240 degree from with reference to VA. डिफरेंस देखिए. सो सीक्वेंस आप वो भी देखिए ना, क्या मार्क है. I don't know if it's clearly readable, maybe
नहीं सर.
हाँ तो हो सकता है ये हॉरिजॉन्टल में, लाइक फर्स्ट जो है ना, जो लेफ्ट साइड में है,
हाँ जी सर,
इट्स VAN. देन ये जो थोड़ा सा स्लैंटेड है जो डाउनवर्ड्स डायरेक्शन में, दैट इज VBN. एंड जो अपवर्ड डायरेक्शन में है स्लैंटेड, दैट इज VCN, जो लेफ्ट साइड में. जो राइट साइड में उसमें हॉरिजॉन्टल इज अगेन VAN, और जो डाउनवर्ड डायरेक्शन में स्लैंटेड है दैट इज VCN, एंड जो अपवर्ड डायरेक्शन में वो VBN है. ठीक है. सो मे भी वही शायद रीडेबल नहीं है, इस वजह से आपको वो हो रहा है, बट सीक्वेंस इज डिफरेंट. आप ऊपर इक्वेशन से ही देखिए.
हाँ जी सर.
हाँ समझ आ गया क्या है.
जी सर.
ठीक है, ABC sequence और ACB sequence, these two are different, not same. Okay, so fine. So let's come to this our current thing that we are discussing. So this current in is Y-Y connection is same as that load current. Now let's see this problem. We have to find the line currents in this 3 Y-Y system. Okay, in this Y-Y connection, we have to find the line currents. So what we have is IA. We have already seen that it's VAN by Z. This Y. Okay, so that is actually 5 minus J2 plus 10 plus J8, and so we get this as IA. Okay, so means this IA will be this 110 by this 6.81 by 6.81 minus 21.8 degree, and IB is, we know that it's minus at one angle of -120 degree, so that will be this, and IC is this. Is it clear? Any doubt in this? Very simple problem. You see that it's a balanced case. All these impedances are same. 10 plus J8, 10 plus J8, 10 plus J8. Okay. So very simple problem, that how to find. Actually, in three-phase network, when you do some practice, you will get the idea that it's nothing but just application of KVL and KCL only. Okay, nothing else. So you just have to apply KVL, KCL. It's based on, it's very simple. Now let's see Y delta connections. Now your sources are in Y connection. Yes, बोलिए बेटा.
सर इससे पहले आपने जो बताया था कि मतलब लाइन वोल्टेज लाइन करंट और फेज करंट सेम होता है, उसका रीजनिंग बता दीजिए।
उसका रीजन तो मैंने आप लोगों को सोचने के लिए बोला कि क्यों, जो आपने बोला दैट वाज वेरी क्लोज, ठीक है। रीजन क्या है, मतलब आपको जस्ट आइडेंटिफाई करना है दैट व्हाट इज लाइन करंट, व्हाट इज फेज करंट। ये जो है ना, ये लाइन मैंने लिखी हुई है, फेज करंट इन वाई वे सिस्टम द लाइन करंट इज सेम एज फेज करंट, ठीक है। हमने लाइन करंट और फेज करंट डिफाइन किया था, क्या होता है। आप एक बार सोचिए, इस सर्किट को एनालाइज करिए कि इसमें लाइन करंट क्या है एंड व्हाट इज फेज करंट।
Sir,
We'll get that.
in last semester, sir told that in star connection, the phase current and that line current is equal.
In star connection?
Yeah, sir.
हाँ ठीक है, फिर
So that's why balance YY connection to their that phase current and line current is equal.
हाँ ठीक है, I'm not asking here for the reason, of course that is a fact, but what I'm asking you is to identify what is line current here, what is phase current. Okay, are you getting my question?
Yes, sir.
So that you are able to identify. Suppose I asked you to solve for line current or phase current.
Yes,
from this diagram you should be able to identify that how to identify what is line, which is line current, which is phase current. Bas, that's all. I know that that's the reason. Reason is nothing. There is nothing much in reason, but you should be able to identify. Okay. So let's come to this Y delta connection. Of course, as I told you, we'll be considering all these balanced cases only. So here we have, as usual, VAN, VBN, VCN. Now we have Y connection for source side and delta connection for load side. Okay. And so line voltage here is VAB. We know that VAN minus VBN. This formula we had already seen, that how to find this line voltage. So it will come out to be √3 VP 30 degree. That we call as VAB. And then VBC will be VBN minus VCN. So that comes out to be √3 VP minus 90 degree. And similarly VCA we can identify. Phase currents you can find out from this. IAB is VAB by Z delta. Z delta is this impedance of this, each of this branch of this load side. Similarly IBC you find, and ICA you can find. Okay. And of course the alternate way of doing is you just apply your KVL and get IAB, but it's both are same, so that's not an issue. Okay, so in this case, now what we have is, we have this line currents you can obtain from KCL. IA, you can see here, IA is this top one, this current, that is equal to IAB minus ICA. So it's just applying KCL. And now we know that what is ICA. So it okay, so your you can express it in terms of IAB. We have just solved it now. IAB is VAB by Z delta. We have identified, and VAB we already know that √3 VP 30 degree. So if we are leaving it like IAB, so you know that ICA can I write like this? ICA is equal to IA minus 240 degree. लिख सकते हैं ना? Yes or no? That's why I have replaced it. Can I write like this? Because it's a
Yes, sir.
Because it's a balanced case. You know that. Always remember, we are working with balanced cases only. And similarly, we have IB equal to this, IC equal to this, and magnitude of line currents IL will be √3 IP, where IP is nothing but this only, IAB, IBC, this that we have already obtained. Okay, so IP is this, your phase current. Okay, phase current we have already obtained. Then we obtained line currents, and magnitude of line current IL is, you can see it from this formula. Okay, √3 magnitude of IAB, that we are calling phase current. And this phasor diagram shows that how these currents are related. Okay, so in three-phase problems, in three-phase networks, the likely problems that you will get will be like most likely it will be based on like most of the times it will be asking find line current, phase voltage, line voltage, those type of issues only. Okay, so these things you will be able to solve when it's all these things are clear to you. So now here let's see that we have ABC sequence. Okay, you are given that a balanced ABC sequence, Y connected source with this VN is connected to a delta connected load with this per phase. Calculate the phase and line currents. So already we had seen the approach. So we have VAN equal to this. VN is given to us. VBN will be this. Okay, because they have to be in Why it's minus 110? Because
ABC load, so B lags A by 120 degree.
120, very good. So it's don't make that mistake that always you will be writing minus 120 degree. You have to see that your reference also. Okay, and so VAB will be this 100 root 3, 40 degree. So phase current we had already obtained. Just see this formula. IAB was VAB by Z delta. So we are applying this formula only. IAB equal to VAB by Z delta. So that comes out to be this, and line current is, we have also obtained this line current root 3 IP or IAB root 3 minus 30 degree. So, okay. So these are simple problems that you can see. You want me to post this slides also in the group if you want?
Yes, sir, you can put it so we can practice it again, the questions.
चलो ठीक है, I'll post this, but do read that book also, please. ठीक है, ये कर देते, चलो जो कह रहे हैं ना कि इनको अवेलेबल नहीं है हार्ड कॉपी जिनके पास. So I'll post this material also in the group, and but do practice these things from the your book also. Otherwise this I'll post in the group. Now third possible case is delta delta. Now delta is very similar, like we had already done two cases. So this is again similar to that. We have VAB, we have VBC, we have V because it's a balanced delta connected. So line voltages are same as, in case of now this case, line voltages are same as phase voltage. Okay, so VAB we are saying as same as VAB, VBC. So your line voltage are same as phase voltage. Now again, here you have to identify that. But still you should identify. Okay, you should be able to identify that why. Okay, the phase currents now as usual VAB by Z delta. So since VAB is same as V small AB and VBC is same as V small bc, so that is how we can obtain. And line currents you can obtain by applying KCL. So IC, let's suppose IC this current you have, that will be ICA, okay, ICA minus IBC, and similarly IB will be IBC, okay, IBC minus IAB. So these are our line currents. We already have phase currents and we are obtaining line currents. So once you cover all these four cases, you will easily see the analogy in that. What is the analogy? So like in the YY case, we found that their line current was same as that phase current. Here we are obtaining line voltage is same as phase voltage. There we obtain phase voltage or line voltages. Here we are obtaining these line currents. Okay, so this is one example. Now on this particular case, we have balanced connected load. Impedance is this, and VAB is given this. We are asked to calculate the phase current of the load and the line currents. So here VAB same as V small ab. So phase currents with this, and line currents you can obtain like this. Any issue in this problem? Any doubt you can ask? These are simple problems just based on the formulas, nothing else. अगर आपने एक केस समझ लिया ना, suppose YY connection, you can easily understand other cases also very easily. Okay, just understand one possible case, others will follow automatically. Fourth case, balance delta Y connection. Now you can see that it says delta. So again, we are assuming ABC sequence. In all the cases, we have assumed ABC sequence, our positive sequence. So phase voltages will be this, as we know. Okay, and now in this case, what we have is we have to obtain line current here, and that we apply, for that we apply this KVL, and it's mentioned that which loop you have to apply, A, N, B, small b, and then coming back to A. So we apply KVL in this loop, and when we apply KVL, we get actually IA minus IB. Okay, so you obtain IA minus IB, and so what we have is, what is IA minus IB then? VP by ZY. VP is 0 degree because it's your this voltage. VAB by, basically you can say that VAB by ZY. Okay. Now to get this, we as like I showed you, IA minus IB equal to VP by ZY, and we know that since it's a positive sequence we have assumed, so IB lags IA by 120 degree, that is IB equal to IA minus 120 degree. So I can write it in this way also, that IA minus IB equal to IA this, doing simplification. So IA you can obtain. Is it correct? Can you do this simplification? And just again making use of this relation between this curves and IB and IA. Okay, and again here it says, since we are talking about this, we have on one side we have delta, on one side we have Y, so we will have get the two possible cases, that here phase currents are equal to line currents. Okay, so delta Y transformation, we have already seen that delta Y transformation, so I'll not discuss. Okay, but this example you can see it in the that when I post it again, you can read it if you want, but I'll as such not required any discussion. Okay, so next what we have is the discussion on the power. So power in this case, what we have is, for a Y connected load, we had already seen these were our phase voltages. So these are our phase voltages for a Y connected load. Okay, VAN, VBN, VCN. We've already seen this when we started our discussion in the last lecture. We just suppressed this omega because we used how we suppressed omega. Okay, let me ask you, how are we able to suppress omega? Because we simply write a VP angle 20 degree or VP angle minus degree or VP angle minus 240 degree. What was the reason? How are we able to suppress omega?
Sir, by using phasors.
Very good, very good. So I'm happy that you remember this, because I use this, that since we are using phasor notation, so we were able to suppress this information on omega, but actually that is present. Okay, you know that omega is present, so it's just suppressing in our representation. So we are bringing back that omega. So it's cos omega t minus 120 degree and cos omega t minus 240 degree, or cos omega t plus 120 degree, as Suprit you are asking. So now here you see that you could have written is minus 240 also. Now if zy equal to z theta, so in that case we are having this IA equal to this,
सर आपकी आवाज नहीं आ रही है.
by this expression. क्या आएगा ये सिंप्लीफाई करके? कौन सी आइडेंटिटी लगाओगे ट्रिग्नोमेट्री की? cos a into cos b क्या होता है? स्टूडेंट्स क्या होता है ट्रिग्नोमेट्री? cos a cos b होगा आप लोगों को?
प्लस cos a minus b by 2
cos a plus b
plus cos a minus b whole divided by 2.
ओके, ये स्टूडेंट्स यही हो cos a cos b का?
Yes, sir.
चलो वेरी गुड, आप लोगों को याद होगा because you must have studied recently only last year. Okay, so we have 1/2 cos a plus b plus cos a minus b. I think this is what you were saying. So p equal to, then in that case VP IP, you just have, we make use of this identity, and finally we do some simplification, like we just apply this property that again further, that cos a minus b, you know that cos a minus b is, what is cos a minus b? That what is the formula for that cos a minus b? It is cos a cos b
Plus sin
b. Okay, so this is what we have done, and we again here we apply a plus b. So cos is b, sin is sin b. Okay, here where alpha is given, here alpha is 2 omega t minus theta. So you do this trigonometric simplification, so you get 3 IP cos theta. So it means, basically what it means, the total instantaneous power in a balanced three-phase system is constant. Okay, it's constant because your VP is constant, IP is constant, theta is constant. So it does not change with time. When I'm saying constant, means it's not changing with time. As although you see instantaneous power for each particular like you have each particular phase, like for first phase, let's say PA, if I find, it depends on T. Okay, it depends on T. You can see here cos omega T minus theta. Similarly for this, it depends on T. But when you find the total instantaneous power, it does not depend on T. That is constant. So that's a like beautiful result that you should remember. So the average per phase, okay, for either delta connected load, because we have not talked about delta or star connected. We just found the general relation. So that will be simply P by 3 or PP equal to VP per phase. Okay, so P here means average power per phase. So it will be VP IP cos theta. We divide it by 3, factor of 3. And the reactive power, what is reactive power? पढ़ा reactive power तो पढ़ा होगा कभी पहले उसमें फर्स्ट ईयर में.
Power supplied to reactants.
अच्छा, पावर सप्लाई टू रिएक्टेंस. ओके, होता क्या रिएक्टिव पावर? मतलब वो क्या, हाँ, कैसे उसका क्या, क्यों हमें डिफरेंशिएट करने की जरूरत है उसे? एक्टिव क्यों नहीं बोल सकते उसे? एक्टिव कहाँ जाती है फिर पावर? एक्टिव पावर विल गो टू
रेजिस्टेंस.
रेजिस्टर. अच्छा, ओके. कैन यू ड्रॉ द फेजर डायग्राम फॉर दिस? एक्टिव पावर, रिएक्टिव पावर, एपरेंट पावर, दिस कॉम्प्लेक्स पावर. कर सकते हो ड्रॉ? पढ़ा तो है ना ये, एटलीस्ट फर्स्ट ईयर में यू मस्ट हैव स्टडीड दिस डिफरेंट टाइप्स ऑफ पावर. यस और नो? अगेन फिर से वही साइलेंट
यस सर.
बैठ जाते हो.
ये सर क्या
ठीक
कहते
है,
हैं
चलो
रियल
बस. हाँ, very good, very good. So just in definitions, okay, I'm not going to cover because that's not a part of this. Just defining those things here again per phase. Next time, if you are not clear, if you have forgotten that what is complex power, apparent power, reactive power, please revise those in your first, those whatever you studied. That will be beneficial here because I'm just making use of those definitions and we are defining those credits per phase. Okay, and the total average power is actually the sum of the average power in each phase. So it will be 3 into PP, so 3 VP IP cos theta, or you know that I can express in terms of this line voltage or line current, it will be root 3 VL IL cos theta. And total reactive power, again 3 VP IP sin theta, or in terms of VL IL, it will be root 3. Total correct power as usual, so it's just a repetition. Okay, so total means we just multiplied by, or we just added 3 times. You can say it like this. Okay, so these are advantages that we have already discussed in the beginning. Okay, so advantages of 3-phase, and these are like quantification of that. As I told you that I told these advantages qualitatively earlier, that these are the 3-phase supply is economical. Like when we started discussion on polyphase, so at that time I told you that 3-phase is widely used, and I gave you the reason that because they leads to that economical transfer of power from one point to the other point. So in transmission, so here it's explained with the help of this. Now once you have understood this 3-phase, so it's explained with the help of this quantitative, this has been elaborated. Okay, like you can get the power dissipated in transmission. We it with this, you have this single phase resistance. Okay, and you can see that if you want that amount of power loss, and the material that is required for 3-phase is less. That's proved here. Okay, so this you can study like it's a simple calculation. Okay, so now tell me, from my side, this concludes this 3-phase also. Now tell, what should we do tomorrow?
Sir, tomorrow?
Hello, sir.
Is it audible, Suprit? Yes, please. My connection got lost. So tell me for tomorrow.
सर आपने तो कहा था आज लोग
Quiz.
क्यूज का
Quiz का बोल रहा हूँ मैं.
सर क्यूज का टुमारो एक दिन में
सर
क्या
आप
करें
मतलब
फिर बताइए.
नेक्स्ट आपने बताया ना पेपर के बाद लोगे, पेपर के बाद ही कर लो सर अब.
नो, मुझे बताइए बाकी स्टूडेंट्स.
पेपर के बाद ही कर लो सर, प्रिपेयर
सर
हो जाएगा
पेपर के बाद
अच्छे से.
पेपर के बाद.
यस सर.
पेपर से पहले आपकी प्रैक्टिस हो जाएगी, लेकिन
सर एक दिन में तो प्रैक्टिस सर मुश्किल पड़ जाएगी.
मुश्किल हो जाएगा. चलो फिर हम एक काम करते हैं. Yes, I promised this thing that we will have lecture on Tuesday and then we won't need any lecture on Wednesday.
हाँ जी.
So as I told you, from my side, these things like I have completed this whatever these 3-phase things were required. Now what else we can do is from like our course for mid-sem is over. Okay, whatever we have discussed that will be there in your mid-sem. Okay, so if you want to ask any other doubt, anything you want, you can ask, and otherwise we'll meet tomorrow.
सर टुमारो को तो शायद आपने मना किया था ना.
हाँ, तो आप बताइए. आप अगर आप लोगों को नहीं चाहिए तो we won't have tomorrow. I have no issue because from my side this course on mid-sem is over, so it's up to you now. अगर आप लोग कहेंगे you just discuss among yourself and then let me know. हाँ सत्यजीत बेटा, आप क्या बोल रहे थे?
सर क्वेश्चन पैटर्न बता दीजिए.
क्वेश्चन पैटर्न बेटा इसमें ये है कि since it's a since I don't need to say this thing, but you already know that it's a numerical oriented course, problem based course. It's we have very less theory in this, so obviously there will be numericals and or problems, and yes, we will have those many problems which you can easily solve in 1.5 hours. So I don't know the numbers, I don't know all these things because we haven't yet like I haven't designed the question paper yet, but I'm just giving you idea that what type of things will be there. So it's a all these things that we have discussed. There will be theorems, there will be these techniques that we have discussed, your mesh analysis, nodal analysis. There will be this two-port networks, and then three-phase networks, and first order circuits. First order circuits we have discussed in brief. Source free case only we have discussed. Okay, so it was very small. So that's all we will have. Means there will be problems, of course there will be problems, so practice as many problems as possible. आप किसी भी source से, यही मैं starting से मेरा point रहा है from the beginning of the course, practice as many problems as you can on this type of courses, because like theorem statement है, Thevenin theorem or Norton theorem or any other theorem, that theorem application is important. So that will be the pattern of the questions, and you will be like, if you practice it, you will be able to solve those things. It's not like this. Any other doubt you want to ask? कोई किसी को और कुछ पूछना है? And anything you want to ask related to mid-sem exam या कुछ भी किसी के mind में, you can ask me now, or otherwise also later on you can drop email or
हाँ जी सर, वो वाइवा का पूछना था कि वो वाइवा का आप कैसे लोगे सर?
वाइवा?
हाँ जी.
वाइवा for what?
वो जो आप कह रहे हो कि आपने पेपर के बाद लेना था, मतलब आप तो कल कह रहे थे
क्विज जो है, क्विज कैसे लोगे, मतलब किस मोड में, whether it will be written or viva or something, ये बोल रहे हो?
मोड में लोगे जैसे कितने क्वेश्चंस होंगे ऐसे ऐसे,
वो तो it's a pattern. If it's in written, it will be multiple choice type thing. Okay. And if it's oral, then of course it will be 2 to 3 questions to every student. 2 to 3 questions each. ठीक है sir. So that will depend, that I'll decide later on that whether I have to conduct it orally or in writing. That I'll be deciding. I have not yet finalized, but first I want from your side कि हाँ भैया क्या आप चाहते हो कि कब लोग, आप लोगों को कब कन्वीनियंट है, आप लोग कब चाहते हो उसे करना. But I want everyone should be present, क्योंकि अगर suppose written क्विज हुआ तो it won't be possible for me to like कंडक्टेड एवरी, मतलब बार बार उसे कंडक्ट करना इजी नहीं है। और बताइए, और किसी को कुछ पूछना है तो? एनी अदर डाउट? ठीक है। सो सुप्रीत, हमने टाइम से पहले ही फ्री कर दिया।
सर
ठीक है ना, है ना?
हाँ जी
सो ठीक है, देन दैट्स ऑल फ्रॉम माय साइड। दिस 3 फेज का जो है मटेरियल दैट आई विल पोस्ट इन द ग्रुप, और आप इसको कोई भी किसी को वैसे डाउट हो तो यू कैन आस्क मी लेटर आल्सो। ठीक है, सो विल स्टॉप हियर टू एंड टुमारो सुप्रीत, फॉर टुमारोज यू हैव टू इन्फॉर्म मी। ठीक है, मुझे एक बार बताओगे आप, फाइनल शाम तक बता देना।